Alright, here we're going to look at 8.6, factoring again, but this time it's going to be the more difficult type. And what constitutes these being the more difficult type is there's going to be a number out front with our x squared. And we're going to see what type of impact that has on our previous method of factoring. Before we jump in, though, to the factoring process, we're going to do some FOIL and see how these pieces fit together, which will ultimately allow us to work backwards as we try to factor. So let's go ahead and FOIL this out. 2x times 2x gives me a 4x squared. Then we'll get a plus 10x from 2x times 5. From 3 times 2, we'll get a plus 6x. And then 3 times 5 gives us a plus 15. And you may notice we have some like terms there in the middle to give us 16x. And then otherwise, we have the 4x squared plus the 16x plus the 15. Let's FOIL out these others and see some patterns that are going to arise. On this next one, we'll have 4x squared. We'll get a plus 10x. We'll get a minus 6x. And then we'll get a subtract 15. And once again, we have the like terms there in the middle to give us 4x squared plus 4x minus 15. And then one final. We get 4x squared. We'll get a minus 10x, a minus 6x, and a plus 15. Now, when I put those like terms together, we'll have 4x squared minus 16x plus 15. All right, so the next part says, what do you notice about the first and last terms in all of your answers? And then what about the middle term? Well, let's start with the first and the last terms. Hopefully you recognized while doing those, or you can recognize now, the first term comes from the first two terms multiplying together. 2x times 2x gives me 4x squared, and that's true on all the ones, and that's why all of them landed at 4x squared out front, because all of these started off with a 2x and 2x. Hopefully you realize that the number on the end, the last number, came from 3 times the 5 to get us that 15. And then sometimes they were positive and negative. So negative 3 times positive 5 to get the negative 15. And negative 3 times negative 5 together to get the plus 15. So what do you notice about the first and last terms? Let's write a little note here. So to get the first term comes from this times this. This number multiplied by that number gives us our first term. Now to get the last term is specifically this number times this number. And none of that is new for us. That's exactly how it was on the original type of factoring that we looked at, 8.6 part 1. What's going to be different is the middle term. Here's what I want us to write for ourselves about the middle term. All right, so that's what we'll use this space for. So we'll say when a is not equal to 1, right? And so what's that mean? 4, 4, 4, right? Any instance to where this number out in front of x squared isn't 1, something different's going to come into play for the middle terms. When a is not 1, our middle term no longer comes from, and then the way it was last week. Because the way it was last week, the middle term came from this guy plus this guy. right? And then also last week, this guy multiplied by that guy gave us the number on the end. That hasn't changed, right? The negative 3 times negative 5 still gives me the term on the end. But those two numbers will no longer add to the middle term, right? That number plus that number will not be the middle. And let's check out that and see. 3 plus 5 is not 16. Negative 3 plus 5 is not 4. Negative 3 and negative 5 is not 16. So there's something different coming here. So let's see where it does come from. So these factoring problems we're going to be looking at are the difficult type. The type that are difficult is when the leading coefficient is not 1. So we'll see this example we're about to do has a 6 out front. On the more difficult type, the middle term does not come from adding the factors of C. It comes from the O and the I in FOIL. It must be double checked to ensure accuracy. So here's what determines the middle term. Now it's going to be, and I like to call it a smiley face, it's going to be this times this, right? That's the O in FOIL. And then it's also going to come from this times this, which is the I in FOIL. So the result is going to be O plus I. That's what's now going to determine the middle term. And if you kind of squint your eyes, it almost looks like that's kind of smiling at you there. So I call this the smiley face method. That's what's going to determine our middle terms. And if we check that back up top, you'll see that that's what was happening. And I'm going to erase some of these highlighters now so that we can go back and see it. Our middle term, which was the 16, did not come from 3 plus 5. It instead came from doing what we just talked about, the O plus the I. So 2 times 5 was 10x. 3 times 2 was 6x. It's that 10x and 6x that gave us that 16x. So here's what that means for us. These are going to be a little bit more complicated to do because I'm not looking for this one, numbers that multiply to 7 that also add to 23. People who don't understand the more difficult type will tell me that this factoring problem that we're about to look at is impossible. They'll say, Mr. Caudill, the only numbers that multiply together to give me 7 are 7 and 1. But those don't add up to 23, so it's not possible. And I'll say, you have forgotten that when there's a number out front, things are more complicated. So let's talk about how to complete these. Now, we know that this 6n squared is going to come from our first two terms multiplying together, which means I could make it 6x and x. Well, in this case, it went in n's. 6n and n. Those multiplied together give me the 6n squared. Now, you might also be thinking, Mr. Caudill, couldn't it also be 3n and 2n? And the answer to that is yes, it could be. Well, then how do we know which one to pick? We don't yet. We're going to have to check all the different combinations. So what I'm going to do is I'm actually going to write us out all the different combinations, and then we'll figure out which one's right by using the O and the I smiley face method to pin down our middle term. So I'm going to go ahead and fill this in like this. Here's all the possible combinations. We know we're going to have to use 7 and 1 to get 7, and we know it's going to be double positive, so it could look like this. All right, and what I have here is every possible option. We wrote out every way to get 6n squared. We wrote out every way to get 7 through multiplication. It has to be one of these four answers. There's no other possible setups that it could be, other than, taking this term and swapping it with that term, but that would be the exact same thing, so we don't have to worry about that. The good news on these factoring problems is that there's only so many combinations you have to check. I often describe it as being similar to where you forgot the third number of your locker combination. There'd only be so many attempts you'd have to make. That's essentially where we're at. We know the combination to get 6n squared. We know the combination to get 7. We just don't know which one's going to be right for the middle term. And we check that by using the smiley face O and I FOIL method. So here's what that would look like. 6n times 7 is 42n. 1 times n is n. Notice that 42n plus n does not give me 23. So that means that this one is not correct. And then we could try this one. 6 times 1 is 6n. 7 times n is 7n. 6n plus 7n does not match 23n. So it's not this one. Let's keep on checking. 3n times 7 is 21n. 1 times 2n is 2n. This one is correct because 21n plus 2n does equal the middle term that we wanted. So this one is the correct answer, and it's the only correct answer. If you double check that third one, or the fourth one, you'll see you get a 3n plus a 14n, which doesn't add up to 23. So it has to be that one solution that we boxed. All of these are only going to have one solution each. You don't have to worry about there being multiple solutions. There's only going to be one possible answer. Now, the other way you could have wrote this, you could have said 2n plus 7, and then 3n minus 1. 3n plus 1, because that maintains the same setup, right? 2n plus 21n still gives us the 23n. So you could have had it that way too. Those are the same answers, just where the factor pieces are rearranged. And that's the more difficult type of factoring. It's more complicated though, because in order to pin down the middle term, you have to double check by using the O and I from FOIL. Let's go ahead and try another one of these. Factor each expression. So the way you do this is we're essentially going to list all the ways to get these first guys. The only way to get 2 is 2 times 1. Same thing for this guy. Which means the only possible setup for this one is going to be 2y and y. That's the only way to, when I multiply those two together, to get a 2y squared. Because remember, these first two terms have to multiply together to give me this. Now, we have to put a couple of things into consideration. When we're looking at the factors of this 2, it could be plus 2 and plus 1, or plus 1 plus 2. Both of those work in terms of multiplying together. 2 times 1 gives me 2. 1 times 2 gives me 2. But only one of these is going to properly work when I do the O and I method to check for the middle term. That's why we'll always have to double check these. So I'll now check it. I'll do 2y times 1 to get 2y, 2 times y to get another 2y, but 2y plus 2y does not match my middle term of 5y, so this one is not correct. If I check this one, though, we'll get 2y times 2 to get 4y. We'll get 1 times y to get y. 4y plus y is equal to 5y. That means that this one is correct. There's a lot to keep in mind and balance on these, on the more difficult type, but the more we practice, the better we will get. Let's keep trying some. So for this, we're going to need to think about all the possible ways to get the two numbers on the end. So there's two ways of getting 6. 1 and 6, 2 and 3. There's only one way to get the term on the end, which is 1 and 7. So this could be 6 in and in. This one's 6 in and in. So we have a 2 in and a 3 in, and a 2 in and a 3 in. You won't typically write out all the different options. I'm just showing you that there is only so many potential ways of doing it, just to make these less intimidating. People get in a big fuss because they think there's an unlimited amount of answers or options, but there's really not. And the reason I chose to write those out twice is because when I'm looking at 1 and 7, I could put the 7 first or the 1 first. The next part's going to involve us thinking about signs. I know I need a positive 7, which means I either need double positive or double negative through multiplication. But when I notice I need them to add to a negative sign, that should inform us that our signs are going to be double negative. And now, here's all the different options. Could be 1 and 7, 7 and 1. 1 and 7, 7 and 1. This is the approach that you would take if you were super confused on this. You would just write out every single possible method that could occur and then check for the middle term with FOIL. And as you do more and more of these, you'll start to get a little bit better naturally the insight on which ones to start with. So for example, you might know not to check this one because 6n times 7 is already way too many n to get that negative 23. So it's not that one. Let's check some of these ones over here. 2n times the negative 7 is a minus 14n. Negative 1 times 3 is a minus 3n. So those will go together to give me a negative 17n. That doesn't match what we were looking for. And I really shouldn't have put an equal sign here. That does not match what we were looking for. Our middle term was supposed to be a negative 23. So it's not this one. Let's check here. Here we'll get a minus 2n. Here we'll get a minus 21n. And these guys, the minus 2n and the minus 21n, do in fact combine together to give us that middle term. And if you've been really confused this whole time on what I'm talking about on this, let's double check this one with FOIL, and then you'll really see why that this particular setup is correct. 2n times 3n is 6n squared. 2n minus 1 is minus 2n. Here we'll get a minus 21n, and then here we'll get a plus 7. And when you combine those like terms, you will get the original expression that we were trying to factor in the first place. And that's what makes this boxed answer the correct choice. Let's try some more. This time, we're going to start off the same. So looking for factors of 7, looking for factors of 8. So that's kind of cluing us in on what potential starts we're going to have. The only starting slots we had worried about is 7x and x. Now there are a couple different ways of getting the negative 8. Alright, so I'm going to write us out a few different options here. And what makes these a little bit more tricky is the fact that it's a negative 8, which means one of them is going to have to be positive and one of them is going to have to be negative. So should it be positive, negative, negative, positive? We don't know yet. We're going to have to figure that out by double checking it, and that's what makes these so tricky. Now, you might even have noticed, Mr. Cottle, if I put 2 and 4, that's different than having 4 and 2, and that's correct, and those negative signs have a bearing on it as well. What you'll come to find out, though, is that the positive and negative signs end up making things a little bit not as complicated as you might expect. All right, so I've checked a couple solutions here. I decided to start with the 2 and the 4 first. Could it be the 1 and the 8? Maybe. But let's start to just check some here with our O and I FOIL method. So when I do 7 times negative 4, we get negative 28x. Here we'll get a positive 2x. And those do in fact together combine together to give us the negative 26x, which makes this one correct. Now sometimes you'll get lucky, and sometimes the very first one that you try will be correct. What that means for all of these other ones is that none of the other ones would work. So for this one, if I tried 7x times 2, I would have gotten 14x. Then I would have gotten a minus 4x. Those wouldn't have combined together to give me that middle term, so that one's wrong. And that means if you tried any of the 1s and 8s, they wouldn't work. Now, something that's important to note, if you would have done something like this, say you did negative and then positive in the 2 and the 4, so notice that the only difference is that I've swapped the positive and negative. Notice what happens. 7 times 4 is positive 28x. Then here I would get a minus 2x, which gives me a positive 26x. We were hoping for a negative 26x. Here's the good news, though. Anytime you get the right middle term, but it's not the right sign, so in this case we needed a negative, what that's telling you is that this answer is almost correct. The only thing you'd have to do is flip-flop the negative signs. So instead of having the negative with the 2, you need a positive with the 2. Instead of having a positive with the 4, you need a negative with the 4. So that takes away some of the potential combinations, which is good. So let's try and continue to look at some more of these. And if you think you're ready, I encourage you to pause this video and attempt these next 2 on your own and see what you can come up with. See if you can get the correct answer, and you can always double check your answer by factoring. So I'm going to attempt this problem, understanding that I have to use factors of 1 and 5, and 1 and 3. And I know that I'm going to need one sign to be positive and one sign to be negative. And as I mentioned, the more you do of these, the more and more comfortable you'll start to become with them. And you'll start to notice things such as, hey, I need this to be negative because I'm trying to reach a negative number. And, negative 14's far away from 0. So I'm probably going to want to use the 5 to help me get a number large enough. And then you might notice, as you do more and more of these, like, hey, maybe I should put the 3 there because 3 times the 5, or the negative 3 times the 5 is a negative 15d. And then that leaves me left over to put the positive 1 here. And then that positive 1 times the d gives me the 1d. And those two guys together, negative 15 and 1, do correctly combine together to give us that negative 14. So that's the type of logic that you'll start to see and get better at. Some of you may see it now already. But when you start to do a lot of factoring problems, you'll quickly find yourself starting to see them a little bit sooner than maybe you once did. Or maybe you have to check less combinations before you find the correct answer. The key to this, though, is practice. No one's going to become an expert on factoring overnight. You do have to just practice it. The good news is that you'll see it for the next several years in math, so you'll get plenty of opportunities over the next couple of years. And I mentioned before I started this, after I asked you to pause, that you can double check these always with FOIL. So I often get asked, Mr. Cottle, did I factor this correct? I would encourage that person to factor it out. 5d times d is 5d squared. Then we'll get a minus 15d, a plus a d, a minus 3. Those do in fact combine right back to minus 14d, which is what we are expecting from the original setup. So one more chance here. If you haven't already, pause it and see if you can figure this one out. I'm going to go ahead and begin it. I'm looking for factors of 2 and 1, looking for factors of 1 and 3. So I'm going to place my 2 in there first. And then for this one, I know I'm going to need one positive, one negative to multiply together to give me a negative. And I want my answer to come out positive. So what I'll need to do is make sure I set this up so that when I do the O and I smiley face method that I get a positive answer. And in this particular case, I need them to combine together to give me this 1 in. The correct choice here is to put the plus 3 here and the minus 1 there, because positive 3 times negative 1 does give me a negative 3. And then we'll get a negative 2 in plus a 3 in. Those combine together to give me the 1 in. So this is the correct answer. If you struggle on that, feel free to write out all the different combinations, because remember, there's only so many different ways that you could have even attempted this one. And that could have been with, you could have tried your 1 there and your 3 there, or your 3 there and your 1 there. These only have so many different ways that you could check it out. So feel free to do it from that approach as well. Now, the final portion, and all the ones I've previously given you have not had a GCF. I did that on purpose so that we could, look at the harder type without having to have any additional steps. But looking for a greatest common factor is really the first step in any factoring problem. The reason we didn't do it on any of the problems previous on this page is I set it up on purpose so that none of them have any GCFs. But otherwise, when you first look at the more difficult type of factoring, and we remember that we know it's the more difficult type when there's a number out in front, you can first decide, are all of these numbers divisible by anything? In this case, the answer to that is yes, and the answer is 5. So what you can do is pull out a 5 from all of those. And when you take out a 5 from all of them, you're left over with that. You do need to do that. The 5 is an expected part of the correct answer. Beyond that, the reason that it's helpful to do that is because I can just put the 5 out front. He's done. He'll just sit there. There's less combinations to check for 4. 4's only factors are 1 and 4 and 2 and 2. If we wouldn't have taken out a GCF, though, we'd have to check 1 and 20, 2 and 10, and 4 and 5. There'd be more combinations to check, which makes it more difficult. So taking out a GCF is actually beneficial to you in terms of making the problem easier. And then this one ends up factoring 2x and 2x, which is one of the factors, and then plus 7 plus 1. And the reason that this works out is because this is 4x squared. Here we'll get a plus 2x. Here we get a plus 14x, which combine back to 16x. And then finally that plus 7. So on these, don't forget to look for a GCF before you try them. I'm going to go ahead, because we're running out of time here, write out the correct answers for you to look at. Take out the GCF first. So on this one, when you take out the GCF, it'll look like this. This one turns back to the easy type, which is even more beneficial. So I will now show you the answers to these for the final portion of the video.